Alrighty, so program comments and docstrings. We already talked about the idea that you can put a header block up at the top of your program. But once we start talking about functions, we should, by all rights, and you'll see me ignore this a lot, put a docstring on functions as well. And so those look like so a docstring is a string literal that occurs as the first statement in a module, function, class, or method definition. See if we can increase the size of that text. All modules should normally have docstrings, and all functions and classes exported by a module should have docstrings. Let's see if they have an example. So here we are. If we write a function, and what a function is just a block of code that's indented under a name so that you can call that function. Looks like this. It's supposed to explain what it does. And the reason why you might want to do that, two reasons. One is so typing is not up speed today. Here we go. Because you can type help and give it a function name. So for example, the print function tells us a lot about it. It tells us that it's got an option to set a separator, an option to set an end, an option to set a file that it's supposed to go to, and a flush option. I've never used the flush option. So anyways, that way we can learn about the help function, or we could learn about the input function. Tells us a lot about the input function. Any function that Python gives us built in, and those are the functions that, excuse me, what is a function? It's got a name and then it's followed by parentheses. So help in itself is a function. This is going to look silly, but let's ask help for information about itself. Ooh, a lot of stuff. A whole lot of stuff. And if we import, trying to think of a library. If we import random, for example, random is a library of functions. I wonder if we can find out more information about it just by typing help random. Oh, 766 lines of help about the random function. Bunch of stuff. Now, normally I just Google it up, right, rather than do that if it's, you know. But here's a function called randint, right? And it says it returns a random integer in the range A to B. So you would use randint to generate like a die roll if you're going to roll a die, you know, in a game of Monopoly or Yahtzee or something. A equals random dot rand int, and I want it to go from 1 to 6. Now I'm going to print A out. I got a 3. Next time I do that, I'm just going to copy and paste it. Or heck, let's do B equals random dot rand int 1 comma 6 and find out what B is. So if we were playing a game where you roll 2 dice and you add them together, right? So that time we rolled a 9. And so we could have found out more information about the random dot rand int function by typing help. So to make a long story short, if we have a docstring, let's go ahead and create our file. What's today's date anyways? It's the 8th. Alrighty. Okay. So I'm going to define a function just called test. Doesn't even do anything except it prints a silly message. So I didn't give it a good name. So DEF followed by the space. The DEF keyword defines the function, and then you give the function a name and you put some parentheses after it, and you put a colon, and then your text is indented under it. And it's important that the text be indented under the function. Pretty much anytime you have a colon, the next line is going to be indented. It's one way to remember. What do I indent and what do I don't? Well, if it's got a colon in front of it, then you indent after that. Well, anyways. And so we're just going to say test function called. Like that. Now, when you write a function, it doesn't mean it's going to do anything. When I run it, come on. It doesn't do anything. Well, then why did I write it? Because we can do it, right? Say it was something that was going to print that message, 3 or 4 times in a row. Until we put a function call and we invoke that function, it's not going to do this. But once it does, once we call it like that, by putting its name, followed by some parentheses, you don't have to have those spaces, it's just to make it easy to read. It's going to run those 4 lines. And lo and behold, it did. So, why do you do that? So that you can, well, for one thing, makes the code shorter, because if I'm going to call that code several times, I don't have to copy and paste these lines of code, right? If I was going to get this to happen, if I wanted it to repeat those 4 lines every time I had that word, I'd have to copy and paste this code so that we had 16 lines here. And we wouldn't want to do that. And your function could be 50 lines long or 100 lines long, right? And each time you invoke it, you wouldn't want to have to just copy and paste all that code. All right, and so it ran 16 times because the function is supposed to print 4 lines, but we invoke the functions 4 times. So it's like this is the recipe, and this is telling you to execute the recipe. If you have a recipe to build 4 cupcakes, and then I tell you to do the recipe 4 times, you're going to wind up with 16 cupcakes total. So if we're going to be good programmers, we should document our functions too. All that one does is display 4 lines of text. It doesn't have any arguments, so I'm not going to list any arguments. What are arguments? Arguments are things that are inside the parentheses that you have to invoke. I don't know if I like seeing that there or not, but now that if I run it, then I could type in help test, and it's going to give that information, right? What does the test function do? It displays 4 lines of text. The arguments, no arguments. What does no arguments really mean? It means when I call it, I don't put anything between these parentheses. Lots of times when you call a function, you do, right? The print function, you better put something between the parentheses. If you don't, it just prints a blank line. So we should be adding docstrings to both our module headers and for each function we write. I don't really like the way that looks. I'm wondering if I tab it, if it's going to look okay. I'm going to run it again and then type help test. Yeah, it looks the same. Okay, good. I like that a lot better. In which case we could probably move these quotes, where we wanted to as well. And another thing this is doing is it is documenting your code. If somebody, including you, opens up a file of Python code and you're trying to figure out what it does, if the functions are documented, you have a much better idea of what the code's doing than otherwise. Now, you don't want to go crazy and add comments to every single line of code, because that can actually make the code harder to read. But documenting what the function does and what the meaning of the parameters are is a very good idea. If you come back to some code you wrote 4 years later, which is very possible, and you're trying to figure out what parameters you need to call to it, you're not going to remember. You can't remember everything you did 4 years ago. And if somebody else is going to use it, which is also possible if you give it to them or sell it to them, then they're going to want to know how to to modify the code, right? If they need to make changes to the code, they need to understand how the functions are called. And reselling code is a very profitable business, right? Video games are made using the Unreal Engine. And they used to be written using the Quake engine. And how did that happen? Well, the guys who wrote Quake took their graphics routines and bundled them up into a package that they could sell to other game manufacturers to use them. And you can be sure that they commented the heck out of that code in order to make it easy for other people to use it, because otherwise people wouldn't want to buy it. All right, so I'm going to just put that down here. We should add docstrings at the top of our code and each function. I don't know why I put a quote there. That's our comment. All right, now back to the PowerPoint. Got 3 participants, Dusty and David. Awesome. I wish this would disappear when I was done with it. You can't see my toolbar, but it's in a way now. All right, either way. So end of line comments, we've seen those. They don't have to be at the end of the line. They can also be the only thing on the line. At the line, you just put the hash sign, the pound sign, and then you can add a comment. So rate equals 0.85. Oh, and what is rate? I sure would like an explanation of that variable, why it happens to be the conversion rate for Canadian to US dollars. So tips related to comments and docstrings. Begin a program with a statement of purpose and other information helpful to programmers. So if I go in and I modify this, I might want to start adding things to my docstrings up here, right? I come back a year later and I modify the test function. I'd want to say, May 13, 2021, modified test function to have an optional argument. How many lines of text to print, right? And if we did that, then we could make it to where if you passed in 10, for example, it would print out 10 lines rather than 4. Now, I'm not going to actually make that change. So this isn't legit, right? We didn't really do that, but it shows you the idea, and then you could have like it'd be a log of all the changes that you made to the code. And this is as useful as information. Put comments in here by itself. You or another program could open up a file, and if you saw a list of changes that you had made to the code, then you already know an awful lot about that code. Oh, now it's up at the top again. All right. You're going to blip around. All right. Accompany a variable definition with a comment that explains the variable's purpose. You'll see me skip that one an awful lot, right? If I'm going to show you how to write something that multiplies 3 to the power 4, I might just go I is equal to 3 to the power 4 and not explain what I is, right? I'm just giving you a little sample code. Now, if I'm going to try to demonstrate writing an actual program, and it's going to have a tax rate, and it's going to have a, a total deductions and whatever, it's a good idea to add a comment for what those are, right? Current state tax, right? And then total deductions, whatever, right? Now you're getting into the category of where the variable names and the comments look the same. But that won't always happen, right? So it's a good idea. But you can clutter up your code too much by putting too many comments. If a variable is not instantly obvious to its purpose, right? Because we could have given this like an abbreviated name. Now, I don't agree usually with the idea of giving abbreviated names. But if you did, you'd certainly want to know what TD was, and you'd want to know what TR was, right? So that's a good idea. Accompany a variable definition with a comment. And so I would say if it's a non-trivial variable, right, or if it's not immediately obvious, of course, that's a judgment call. We should add docstrings at the top of our code, and for each function we write, we should add a comment to our variables to explain their purpose. Now, at a certain point, I might start counting off if you don't do this stuff. At the beginning, I don't think I'm gonna, although I had to get you in the habit of it. If I ever make a requirement of it, I will certainly list in the homework itself that you better follow, some rules, and then I would prepare a rules document. And that's something I ought to do. Maybe by next week I'll be asking you to write properly documented code. If you work at a professional company, you're going to have requirements that you have to follow. So we may as well get in the practice of doing it right now. Precede major segments of code with brief comments that explain their purpose, right? So you have 5 lines of code or 10 or 20 lines of code that open a file, read the data from it, and build some kind of internal structure. We'll put some comments above that code explaining it. Now, if there's a little comment block above that block of code, then that might be more easy to read and understand than if you add a comment to every line of code, because again, that clutters it up. And then include the comments to explain the workings of complex and tricky sections of code. You know what? I'm just going to copy and paste. If you're trying to type along with me, I apologize for doing that. Well, I guess I could type it. Comments above blocks of code. What was it they said exactly? Major segments of code. They're just like chapter titles, right? Chapter 2, chapter 3. You're breaking your code up into chapters by spacing them appropriately. What was that last one? Include comments to explain the workings of complex and tricky. I closed it again. Now, nobody wants to write comments, right? When you're writing your program, you don't really feel like, adding a hash and explaining it, but do it. Professional programmers add comments to their code. You just don't want to overdo it. The harder the code, the more comments, the harder the code is to read. It's a balance. So the first applications to computers were to crunch numbers. That's pretty much absolutely true. Well, for one thing, they couldn't do much else, right? You had a great big machine the size of a room. The Americans built computers in order to, be able to produce better weapons, Manhattan Project kind of stuff, or to build, artillery tables, or, bomb drop, calculations and stuff like that. While the English tended to build computers in order to crack codes, such as the Enigma code that the Nazis used during World War II. Different purposes, but they still involve numeric calculations. So integers. Integers are whole numbers. In real life, the range of integers is infinite, right? You can have a number of however many digits, but a computer's memory places a limit, right? We don't have memory the size of the universe. And so the standard size for an int is 2 to the power of 31. That's the largest it can get. Now, honestly, I don't know how big that is, but we can type in pretty large numbers into idle, larger than in a lot of other programming languages. right? So what is 2 to the power of 21? 2 to the power of 21. Okay, is that all? You can get numbers larger than that. Well, maybe they get converted to floats. That's only 2 million. X is 2 million. 1, 2, 3, 4, 5, 6. Y is going to be 2 billion. 2, 3, 4, 5, 6, 7, 8, 9. And Z is going to be 2 with even more zeros, right? All right, let's run that. I'm going to get real tired of seeing that. And let's find out the type of X that was created. It was an int. Let's find out the type of Y. It's also an int. Type of Z. Also an int. So that slide is wrong. Let's really find out the max value of Python int. You can get it out as sys.maxSize. Okay, in Python 3, int is unbounded, meaning it can be as long as your program. That's pretty wild. I did not know that. All right. Let's find out what type A is. See, I actually have to run the code before I can do this kind of things because the code has to execute, so all the variables are loaded into memory. Hey, it's an int. Okay, that's pretty amazing. Cool. All righty. Something to remember. The book says that the maximum int is 2 to the power of 21. That was for Python 2. Python 3, there is no max. It's supposedly, quote, unbounded. It's limited how many digits you can stand to type, right? That's amazing. Could we do one that was 1 billion digits long if we wrote a program that was, you know, a gigabyte long? Don't know. And then there are so-called real numbers. Those are floating point numbers. So ints are whole numbers. Reals, well, no, floats are numbers with decimal points. In this language, the difference between the two does not matter as much as it does in certain other languages. However, there are times when you have to use an int. We're not going to hit any of those in the beginning. A lot of code examples will show using ints, like if you're going to get input, you know, if you do x is equal to input, and then you change it to an int, right? Like that. Well, that code would blow up if you typed in a number with a decimal point. Now, usually if you ask for somebody's age, they're going to say that they're 32 rather than they're 32.1. So that's usually a pretty safe assumption. But you'll see me use floats almost all the time, just so that it won't crash, right? If we're going to ask for the number of grams for a conversion, we should ask for float because somebody might want to know the conversion of 22.5 grams. And by the way, 22 is an int. 22.0, even though it's a .0, is considered a float. You would think, well, they're the same value. Well, according to our math systems, they are, but according to the computer, they're not because they're stored differently. We can prove that to ourselves. I'm getting tired of seeing this stuff, so I'm going to comment out those 4 lines. So let's do this. Let's make an int. I guess we have our variables x, y, z, a, so b is equal to 2, c is equal to 2.0. And when we run them, we're going to see that the type of b is in fact an int, the type of c is in fact a float. However, Python is going to say that they're the same thing, even though they're stored differently. It's kind of like if you have a sentence that's written on parchment and then you have a sentence that's copied into stone. If they're the same sentence, then we could say that they are the same sentence. So if we did if b is equal to c colon print yes, it's going to print yes. Right, because they are. They're not the same type. If we did if type of b is equal to the type of c, print yes, it's not gonna, right? Because they have different types, but we can consider them to have the same value. You can also use scientific notation if you feel like. I'm not going to really get into what scientific notation is. It's when you have an exponent. And so 3.78 times 10 to the 3, that means that you're going to move the decimal point over 3 times. And so that number is really equal to 378 or 3,780. If you know what scientific notation is, great. I'm not going to ask you, what is scientific notation? But you may see me use that very, very occasionally, but probably not too much. And then there are 2 other functions. These functions convert letters into their Ascii values. The Ascii value of A is 65. The Ascii value of lowercase a is 65 plus 32. I just happen to know that, and so that would be 97. So, ordinal value of A is 65. And you can also go the other way. The character value of 97, ASCII value 97 is translated to human readable text as a lowercase a. And I'm sure that I did a for loop to print out the ASCII values of letters. Why not show that again? So we're going to create a string. A string is a sequence of text characters enclosed in quotes. You can use single or double quotes. Other languages are very picky about whether you use single or double quotes. This one is not. So for example, I could say that my name was equal to Fred. And now I'm going to write out a loop, and I'm going to go ahead and make this all complex. So if you don't totally get it, that's fine. If you do totally get it, even better, right? I'm going to write a for loop that says for every character in name, print out the ordinal value of that character followed by a space, or maybe a comma and a space. Siri, I did not say Siri, I said space. And then when we're done, we're going to want to go to the next line. Now, putting an end parameter stops print from going to the next line. Otherwise, print always goes to the next line when it's done. Okay, so it's going to print out Fred, but it's going to print out the numbers instead of how it is stored in computer memory and if you save it to disk. All right, so FRED. And if we went to AsciiTable.com or we otherwise Googled an ASCII table, right? AsciiTable.com, we'd see that a capital F is in fact a 70 and a lowercase r is in fact a 114. And if we go and look at the results of our code, 7114. Now, one way of hiding code, and you would not use this, you know, to try to create a code that could not be broken by the Russians, but it's the simplest cipher, is to create what's known as Caesar's cipher. And what Caesar's cipher is that you shift the letters. Like if I had the word dog and I wanted to use Caesar's cipher on it, I could just shift D's to E's, right? Element O's to P's and G's to H's, right? Because there's one past it, right? So that's Caesar's cipher. If we wanted to print the numbers out from Caesar's cipher, we could do that just by adding 1 to them, right? And now it's no longer going to equal those values. It's going to equal, right, 71, 115, 102. And then you could convert those back to ASCII digits if you wanted to. And instead of saying Fred, it would show G and S and A, B, C, D, F. And well, I'm not going to do that. And that's the idea of Caesar's cipher. We'll hit that in a later chapter. So if this line doesn't make sense, that's okay. Whoopsie. I tend to show you things twice. I tend to show you things once before we talk about it in the PowerPoint. And then once we hit it in the PowerPoint, and that's what the reason for that is so that when you see it in the PowerPoint, it's actually nailed hard down in your mind. I mean, we could have used a for loop just to print the letters out, right? For CH in name, print CH, and it's going to print out FRED. Right? And then it's going to print out the numbers. So we could have printed out CH followed by the ordinal value of CH, the ASCII value. Right? So FRED 70, 114, 101, 100. Now you can go the other way too. And again, this is leaping several chapters ahead, but I'm going to make a list that has those values in it. Where was our output? Oh, I guess I'll have to run it again to get the output. Okay, I'm going to just make an easy one. List is equal to, and what is a list? It's a sequence of numbers that are enclosed in a brace because they're not supposed to be treated the same thing as a string. So a 65 is an A, and a 66 is a B, and I want to spread out the word Abe, like Abe Lincoln. So C would be 67, a D would be 68, and E is going to be a 69. So you see what a list is. It's just a sequence of numbers. Or it could be a sequence of strings or a sequence of any kind of data. All right, now I'm going to write a for loop that's going to print out these numbers and then their ASCII values. For every item, I'm going to use V instead, for every value in the list, colon. Now, you'll usually see me do lowercase variable names, but for lists, I use uppercase variable names because if I put a lowercase L there, it looks like a 1. Personal quirk. So for V in L, print out that value plus the character, the ASCII character that can be made from that value. And this just goes the other way. If ORD gets you the ASCII value, then CHR takes that ASCII value and sends it back to a string. Right? And so these ASCII values that I put in that list, when translated into human readable text, forms the word Abe. Okay, now this is a crazy statement. A literal evaluates to itself. And I'm going to just blow that off. What is a literal? It's a number or a string that's typed directly into the code, right? It's not calculated. It's not typed in by the user. It's not read from a file. It's typed in directly into the code. And so I have a literal here. That's one literal. That's another one. That's another one. That's one. That's a literal, right? These are numeric literals. Some people call them unnamed constants. And then that's a literal, right? Because the user has no control over it. It's going to print out Fred every single time. They would actually have to edit the source code in order to put their own name in there. They would literally have to edit the source code in order to change it. So what is an expression? An expression is something that evaluates. X is equal to 55 plus 66. That's an expression, right? That's how we normally think of an expression, is numbers separated by symbols. And what the how the expression evaluates depends on the symbol, right? 56 plus 66 is going to be one value. 56 plus or times 66 is going to be a completely different value, right? So, example of an expression. 56 plus 66. Same for the next one. You can have all sorts of expressions. There's an infinite number of expressions you can make because you can create an infinite number of variables, right? You can create an infinite number of values, and you have these symbols, right? So even if I only had two, that doubles the possible number of expressions. Plus, you could have more than two symbols in it. 56 plus 66 times 76, right? Divided by 86, right? Longer expression. Expressions provide an easy way to perform operations on data values to produce other values. If you enter that into the shell prompt, it's evaluated and then immediately displayed. That's not what happens if you enter it into the program. It doesn't print anything. But if I went to the Python shell and just pasted that, it's going to print out what it is. Back in the old days, when you had an Apple or a Commodore, or an Atari computer, it did not boot to a Windows graphical environment. Instead, it booted up to a command prompt, and you could type in math just like that, right? And nowadays, they don't do that, but you can always get to math just by loading up Google, right? And then if you load up Google, you can type into Google or in the address bar. So I just about never use a calculator. I just open up Google and type in my expression. So with expressions, those symbols can be arithmetic operators, right? A minus sign means subtract. A plus sign means addition. Notice that they list minus twice. That's just a little bit weird, but all it means is that it can be used in two different ways, right? If I say A is equal to -7, we're not subtracting 7 from anything unless you think that there's going to be a hidden 0 there. That's called negation, right? It takes a minus value of whatever follows. Now, I don't think you can extend that. I could be wrong. If you do B is equal to -x, is it going to take the negative value of that? I don't know. Let's try it out. I'm going to go back to the shell and type in A is equal to 3, and then B is equal to -a. And what is B? What do you know? All right. I've honestly never used that. If I was going to use that in a program, I would have said 0 minus a, right? But it works. Okay. So this is an example of using minus as negation. But how do you normally use minus? I'm calling it minus like I'm a grade schooler. It's subtraction, right? And these work exactly as you would expect, right? So I'm not going to define subtraction. And then, of course, you have addition. You have multiplication. You have, what else? Division. I don't know why I put a plus there. That's not correct, is it? Then you have a couple more, a little more specialized ones. Slash slash means floor division, which rounds down, right? So 3 goes into 5 1.666 times, something like that. But 3 goes into 5 rounded down, just 1, right? Because you can only stick 1 3 into a 5. So that's called floor division. Let's see if that's the same term they use. Of course not. Quotient. I'm going to call it floor division because a lot of textbooks call it floor division, but the book calls it quotient. And then you have modulus, which stands for remainder. When 3 went into 5 one time, what was left over? Well, 3 goes into 5 one time with a remainder of 2. So that's what percent sign gives you. If I did A is equal to 5 modulus 3, remainder of 2. In our example, right? And so this was a 1 in our example. Hate to go past the end of the screen, but I guess if I nudge this over, right? That's about them all, except for star star, which means exponent. Which means to the power of, right? And again, you can do all this in the shell if you want easy answers. Does Google support slash slash? If I type in 5//3, does it go? Nah. All right. It certainly would tell me 5 divided by 3. How about 5 modulus 3? It did do that. Well, I wonder what they want to use to the power of. If I take 5 to the power of 7, well, it can do that, but that's just like a calculator. That doesn't tell me how I should have typed it up here to get that result. Oh, well, anyways. Oh, I bet you use the up arrow, right? If I'm in Google, and I type in 3 to the up arrow 2, okay, all right. It's a pity that the languages don't do that because everybody wants to use the up arrow anyways. It's just that I've known for so long that up arrow doesn't do that in programming languages, at least none that I've used, that I had forgotten that it did it. So 1, 2, 3, 4, 5, 6, 7, 8. Is that how many we got? 1, 2, 3, 4, 5, 6, 7, 8. Yes. Now, symbols are grouped together by their precedence, their priority, because you probably know that if you have this expression, A is equal to 2 times 3 plus 4, and let's make it 2 plus 3 times 4. That is not calculated like it would be if you had a dime store $10 calculator, right? If you typed in 2 plus 3, enter, that would be 5. And then you typed times 4, enter, it would give you 20, right? But that's not the way mathematical expressions work. And you probably know this from your math classes in the past. This gets done first, right? If you typed into one of your scientific calculators or something, your TI-30, something like that, if you typed in 2 plus 3 times 4 and then hit enter, 3 times 4 would be evaluated first, and it would come up with 12. And then it would add 2 on it, and you'd get 14, right? So the star happens first, then the addition. So 2 plus 3 times 4 is the same thing as 2 plus 12, which is the same thing as 14. That's called operator precedence. Let's make sure that that's what the book calls it. Yeah, here we go. Or precedence rules. That is dictated by rules of precedence. Operator precedence. And the rules go like this. Although the book doesn't list this, you know what? I'm just going to put a multi-line comment. I could have opened a multi-line comment up here, right? But anyways, the rules are that parentheses force something to be done first. So parentheses are at the top of the heap. And then exponent, right? And then multiplication and division, and all of its variants. What is considered variants? Floor division and modulus are also considered variants of division. So multiplication and division. And then add and subtract. And there's a mnemonic, a little key phrase that you can remember for this, that you might remember. PEMDAS. And the phrase for it is, please, I did not make this up, please excuse my Aunt Sally, right? So if you can't remember the order of these, you just remember, please excuse my dear Aunt Sally. And you probably do remember these from, math classes, junior high or whatever. If you've forgotten, please excuse my dear Aunt Sally. Parentheses happen first. They force that to happen first. Then exponents happen. And then multiplication and division happen. And then addition and subtraction happen. Now, these are equal. So it's not like all multiplications are done before division. It's just as it's going left to right. If it finds a multiplication or a division, it does it. So if we make a more complex phrase, A is equal, well, this isn't going to be that much more complex. But if we really wanted the addition to happen first, A is equal to 2 plus 3 times 4. What happens first? Come on. Multiply happens first. But if we wanted the other part to happen first, A is equal to 2 plus 3 times 4, right? Addition happens first because of the parentheses. And if you didn't know all this before, you know it now, right? If you have a scientific calculator, you can use the parentheses key to force part of the expression to happen first. With two exceptions, operations of equal precedence are evaluated from left to right. Now, that's what I was talking about. If they are of equal precedence, you just solve them left to right. Right, if you do A is equal to 3 times 10 divided by 5. Wait. Let's see if we can come up with something a little bit better. 10 I'm not sure I'm going to be able to come up with something that makes sense. But anyways, the star, yeah, this is a good example. Well, PM does. M happens before division, right? So I should do that first. So 5 times 2 is 10, and then it's 10 times 10 is equal to 1. No, that's not how it works. Instead, since they are equal priority, you just do them left to right, right? So 10 divided by 5 is 2, and then multiplied times 2 is 4. So equal precedence is done, solved left to right. And the book gave a fancy term for that, right or left associative. It didn't even define that, but it goes left to right, which is left associative. However, it says that star star is right associative. So if you have a is equal to 2 to the power of 3 to the power of 4, I'm not sure why it matters, but 3 to the power happens first, and then it goes one to the left. So it goes from right to left. So it's right associative. And the same for the single equal sign, right? Star star is solved right to left. I should say evaluated, which is right associative. I'm not going to ask you those terms. You go on to get a computer science degree at a 4-year college, they may start using these words. Left associative just means that they're solved left to right. That happens before that. Star star is solved right to left, so it's right associative. So star star 4 happens before star star 3, right? Or I'm just going to say the other. Suppose the equal sign, right? The equal sign is the absolute last thing that happens, right? This is also right associative because everything on the right-hand side gets abbreviated RHS happens before the equal sign copies the value into the variable on the left. Now, this act of copying has a technical name too. We got to have technical names for everything, don't we? That's called assigns. So equal is the assignment operator. You could put it down at the very bottom of the list, right? Because it's the very last thing that happens. I'm not going to even do that because it's not part of PIMDES. But I am going to make the comment that also floor division and exponent are at this priority, right? They just don't fit into PIMDES, so I don't list them. Maybe we could come up with another expression that has floor division or quotient, as they called it, and modulus. And use parentheses to change the order of evaluation. So when both operands of an expression are of the same type, the resulting value is also of that type. You add 2 integers, you get an int. But if they're of a different type, the resulting value is of the general type, the more general type. Floats are more general than integers. Integers have the restriction that they are whole numbers only. Floats are more general because they are not limited to being whole numbers only. So if you do a division of No, oh, by the way, this is a total lie. Man, this is written for Python 2 and they didn't edit it. Why do I say it's a total lie? If I go and type 3 divided by 4 into the Python shell, it's not going to equal 0. It's 0.75. So ignore that completely. Well, sometimes it'll be true. But the example is wrong. I don't know how to fix this. What do I mean by sometimes it'll be true? If you multiply two numbers of the same type, right? An int times an int is an int, but an int times a float is a float. We could give examples of that, right? 3 times 4 gives us 12, but 3 times 4.0 gives us 12.0. But I think all division gives us floats. That's how you could fix that. When each operand is of a different type, the result is of the more general type. So 3 times 4 is 12, where 3 times 4 is 7.5. No, it's not. It's 12.0. Exception. Division always produces floats. So for multi-line expressions, you can use a slash to continue it over one line. 3 plus 4 times slash 2 star star 5. Right? If you're typing a line of code and it gets to be too long, all right, I closed the string so that I'm now adding comments again. Right. So I'm going to say A is equal to 2 plus 3 times whatever, right? And then I want to continue that on the next line. I use backslash. So, and then I could add another 12, and I could multiply that by 100, and I could modulus that by 4, and I could multiply that. Okay, I'm going to continue on the next line, right? There. And it would solve for 3. Who knows what that is, right? And the backslash works for other things, not just division. I could do this, right? Print hello there, end quote, and I want to print out the number 2 and then somebody's name, but there's even more things I want to print, right? So after the comma, I might put a backslash there so I can add more things to put. And so when I run it, it's going to say hello there to Fred something else. Now, honestly, I think in this particular case, if we remove that, it would still work. But there's nothing wrong with being safe and adding it. Yeah. It's like once you're outside all the quotes and you put a comma, if the last thing in the statement is a comma, it'll allow you to extend it to the next line anyways. But why not do that? Nothing wrong with doing that. So putting a backslash at the end of a line will continue it to the next line. All right, guys, we've been at this for about an hour. Let's take a 5-minute break. Before I do that, I'll ask, are there any questions? I've been checking for comments, but it doesn't look like there are any. Are there any questions over what we've covered so far? Maybe we're all good? All right. 5-minute break. Please remind me to start the recording. Hey, gang.
Hey.
All righty. So Dave and Dusty, remind me, did y'all take 1113 or is this all brand new?
This is all brand new to me.
Oh, cool.
I've had the intro class, and it yeah, I actually thought you were the this class when I enrolled in it was under Professor McWaters.
Right.
That's who I had my intro class with. I thought you were Professor McWaters at first, and when
Yeah,
I
they gave
saw
it to
you in the
me.
group, I thought you were just another student. So I
Oh, that's fun. Yeah. I guess I should have made that clearer in the announcements. By the way, guys, you got a new teacher. All right, so let's get back into the saddle. This time I'll remember to resume the recording. Well, I'll be happier for that. All right, how do you resume the recording? It's still recording and the share is gone. That's what happened. Ah, great. All right, something to edit out. Go away. Go away. So mixed mode arithmetic involves integers and floating point, right? Like I said, this stuff doesn't really matter all that much unless you have to get an integer as a result. And if I had to get an integer as a result, I would just use the int function, right? Like if I wanted to make sure that a is equal to 3 times, you know, let's say that a is equal to 4 and then b is equal to 5, and I wanted to store a times b, but I wanted it to be an int. Here's how I would make sure. Right? So that does the multiplication, and then it converts it to an int. It rounds it down. So I don't care so much about that mixed mode arithmetic and whether something's going to produce a float or not, because I know I can turn it into a float, or I know that I can turn it into an int if I need to, right? If I wanted to make sure that c times b was a float, even though it won't be, because an int times an int makes an int, I would just do that, right? And really, although they spend several pages on this, you're never going to really, I won't say never. Long as you remember you can make it an int or a float if you need it, then all other worries are gone. So you may be asked a quiz question over it, and then past that, I'm not going to ask you a question. I'm not going to give you something like this and ask you if it's going to give you a float or an int, because you could change it into either one if you needed to. And that's what they say. You must use the int or the float function, convert the string when performing. Why is this larger than the screen? Right. So the conversion functions, int would 3.77 would turn it into a 3, right? It'll also go from a string to an int, which is why we use it when we get input. The user types in quote 33. Well, they don't type the quote, but as soon as the input function is done, it's inside quotes. And you call int on it and you get 33. And there's one that goes the opposite way as well. If you want to take something and you convert it to a string, it'll do that. Now, you don't normally need to do that, but you can do that when you need to, if you need to convert something to a string. What's an example of doing that? Why don't we just do it in the shell? You know, a is equal to 2 plus 3. Print out a. Well, that's a 23. But what if we had a B is equal to int of A, well, then it's going to be 23 without the quotes because it got turned into an integer. And what if we wanted to turn it back into a string? C is equal to str of B, right? And now when we print out C, it's back to a string. About the only time, well, I won't say the only time, but about the only time that I've ever done that is if I was printing something like the answer is, and I didn't want a space there. I don't know, like if I had a colon there, I really didn't want to put a space there. How about like I called it, age, and I wanted a colon there. Well, right now when I do that, it's going to put a space. That's because every comma encountered in the print gets turned into a space. Now you can control that if you really want to through a parameter to the print statement, but it's easier just to do this. Remove the colon and then convert that value to a string. Now that works, right? It took the space out because converting it to a string let these two things be added to each other. Plus sign works with strings, but it's not really doing adding. I shouldn't have called it adding. I should have called it concatenation. Concatenation is when two strings are added together by appending the second one to the first one. And so that gives me output without the space. So if I ever want output without a space and the second value is a number, then I would use str. Hope that makes sense. I guess I'll list in our code 3 conversion functions. Int, float, and str. Converts argument x into an integer, a float, or string, respectively, right? So type conversion occurs in the construction of other strings. This is just what I was talking about. If you want to build a string that's got a number in it, you call str. When would you want to do that? If you have, you want to make a string that says, age equals 23, my output is equal to age equals plus 23. It's going to error out, right? Can only concatenate a string, right? These two things have to be of the same type. If one is a string, the other better be a string. So I could do output equals, quote, age equals, end quote, plus str 23. And then when I type in output, right, then when I print the output, it'll print my string. Now, I don't normally build my output strings before I actually print them. I usually just include all that stuff right there. But this is a legit way of doing it, right? You could create your output and then you could print it out. About the only time I see that or do that is if I have a function that's going to return the output string and then I'm going to print the results of that function. And that's way beyond what we're doing right now. So Python includes many useful functions which are called modules. It's too big again. Get smaller. They're organized in libraries of code called modules. For example, the random library to generate random numbers. The math library has math functions in it. The turtle library has turtle functions in it. The turtle library is kind of fun. We'll play with turtles after a little bit. Maybe we'll do a turtle right now. Import turtle. Now I'm going to make a turtle to draw on the screen. Leonardo. Leo is equal to turtle. Who cares about this syntax? I'm not expecting y'all to actually get this. And now I've created a turtle on the screen. So when I run it, we're going to see that turtle on the screen, although it's not going to look like a turtle. It's just going to be a, oh, what did I do wrong? It gave me an error and I skipped past it. I didn't see it. It did not like the backslash there. Maybe because I have something after the backslash. Yeah, that was it. All right. It created a window and it put that little symbol in the middle of it. Now this is a drawing library. I can make this go in whatever direction I want to, right? And turtle first programming turtle. See if there's a picture of it. It was a mechanical device. Yeah, it looked like that. Do you remember when the BB-8 toys were real popular, you know, after the first of this trilogy Star Wars movies, and you had the round robot who would roll around? Well, imagine if he had a pin that could extend, and you told him to go forward 2 inches, and then you told him to go right 5 degrees, and you told him to go forward another 2 inches or whatever, right? He could draw something. Now, that's a pretty sophisticated turtle right there. I'm dubious that it could draw that well, but there's a picture of it. Anyways, of course, we're using an electronic one. So I'm going to make the turtle go forward. Leo.fd for forward. He's going to go forward 100 pixels, and then he's going to make a right turn. A right turn is 90 degrees. And then he's going to go forward another 100 pixels. We'll tell you what, if he does this 4 times in a row, he's going to make a square, right? Because you go forward, you turn right, you go forward again. And if you did that 4 times, then it'd be a square, right? So there we go. Anyways, Python doesn't know how to draw all this stuff, but it did after we imported a library. The turtle library gave us the ability to add functionality. And there's all sorts of libraries. A library that might be fun for you to look at is called Pygame. It's for actually creating video games using Python. Now, are you going to implement Call of Duty using Python? No. Because Python is not a fast language comparatively, not like C++. But anyways, here's a video. Pygame for beginners.
Guys, welcome automatically pixel version. So I'm going to take subtracting values from x and y coordinates of
and there's of course all sorts of video games you can program with Python.
Multiple bullets.
He's making some kind of Space Invaders game where spaceships are moving around.
X and it was having multiple bullets.
Oh, come on. Show us your game.
Direction by reducing the value of y. So guys, this was the logic
forget
of our bullets. In the next video, we are going to tackle the 2 problems that we have.
Maybe another example. A shorter one, easy to move around here. This one's 11 seconds long. That's pretty awesome. I want to know how to do that. I want to learn Pygame. Then I can make it, you know, part of the curriculum because people would really dig doing that. So Pygame is a library. You have to install it separately, though. You can install new modules. The math library, the random library, the turtle library. All of those are libraries that we can use. Turtle. These are common libraries, but we'll find others, I'm sure. Use import. All right, I don't want to draw a turtle each time I run this program, so I'm going to comment this stuff out. There, put 3 triple quotes at the beginning of it, 3 triple quotes at the end, and it's commented out. There's another way I could comment it out. If I'm using idle, I could highlight all that, go to format, comment out, and it just adds stars to it, right? I mean, hashes. If I ever decide I don't like that, if I want to bring that code back in action, take it out of retirement, uncomment, then we're back to good. So you can comment code either way. I usually use the triple quotes just because it makes the screen less cluttered. However, in the notes that I upload, I usually don't take the time to colorize it, and so it's all black and white. And so it's harder to detect what is comment and what isn't. And so it's a legit thing to say that I might want to comment my large blocks of text by doing that. But that's harder to read, right? I don't know. The best thing is for me to do is just to colorize all the notes, and then you can see them. I try to do that. So I'm going to comment it out like that. We're getting close to the end of the PowerPoint, I believe. So what we're going to do after that is we're going to go solve a programming problem or two. So a function, maybe not because this is awfully important. Well, we'll see. A function is a chunk of code that can be called by its name. Functions often require arguments or parameters. Well, what's the difference? If I write a function, which I'm going to do, then when I define the function, this one's going to be called hello, but it's going to take a name so that we can greet the person by name. And so we're going to print, I'm getting all fancy here, some asterisks, but we need we're going to build a string, which is hello plus their name. And then we want to print a line of asterisks that's the same length as the string. And like I said, I'm getting really fancy. And then we're going to print that string. And then we're going to print another row of asterisks. Tell you what, we need to just give that a name because this is looking pretty complicated. How about we call it dashes instead of asterisks? And so I'm going to cut that. And I'm going to make as many dashes as I need to print out to the same length as this string. So a dash, and the times means repeat it that many times. And so I can print the dashes, I can print the string, and I can print another row of dashes. Again, I'm throwing stuff that's a little bit more complicated. It's okay if you don't totally get it. I do want you to get the idea of writing a function. Now I can do hello, and we're going to say hello to Joe. We're having a presidential debate, and we're going to say hello, Donald. And we're going to see that each time we call this function, it runs this block of code to print hello in a nice fancy way surrounded by dashes. Right? There we go. This is called the parameter. The thing between the parentheses are parameters. How about I make that plural? Because you can have none, you can have one, you can have 20 parameters. If you don't have any, then you better not pass in anything, right? We could write another function called hi that all it prints is hi there, right? This one has no parameters. When a function's code is done, you just unindent. That's how Python knows that it's the end of the function, right? So we have a beginning function there, it ends there, the beginning of the next definition is there, it ends there. Indentation is very important in this language. So we're just going to say hi like that, and it's going to print hi there. Or maybe we're going to say, let's debate. And so this one doesn't take any parameters. Now, when you're calling it, colloquially, you can say, okay, here's the Joe parameter and here's the Donald parameter. Now, if you want to be computer science specific, expert programmer specific, you're instead going to say the argument. This is the argument that fills in the parameter. Joe is the argument that fills the name parameter, right? So when it runs, this value is copied into that variable. Same deal for here. Donald is copied into that variable. So Donald is the argument here. And then this function requires no arguments. Now you can write a function that only has optional parameters, meaning that they don't have to be called. You don't have to add parameters for it to work. The print function is like that. Okay, so print doesn't require any parameters and it'll work just as good. It'll print a blank line. Or you can give it, there I go calling in parameters, right? Now I'm giving it an argument, so it's going to print that. And now I'm going to print it out, and we've given it another argument. If we give it an end argument, it tells it to end whatever it's printing with this stuff. Like maybe a couple of blank lines, a row of exclamation marks for no good reason, and then a couple more blank lines, and then print why did we do that. Right? So this is an optional argument, right? We don't have to have that there. We didn't put it there. We didn't put it there. But if we do, it changes its functionality. Right? So we printed out hello, and then it printed out some blank lines, and it printed out some exclamation marks. What you normally use the end parameter for is to stop it from going to the next line. Print, I am so, end quote, comma, end equals nothing. I don't want you to end anything, right? Or how about we just put a space here as our end? And then we can print glad to see you, right? The end argument says, I don't want you to go to the next line. Don't print out a new line. Instead, just print out a space. And there's one more optional argument. Do you remember when I said that everything separated by a comma gives you a space? You can control that by using the Scp parameter. Print my, comma, name, comma, is, comma, slim, comma, shady, right? And so when we run that, it's going to say, my name is Slim Shady. There we go. But we can add an Scp parameter, which stands for separator. Right now, it's separated by spaces when it prints out. But what if we want to print it out separated by, I don't know, asterisks? Now when it runs, the spaces are going to have been replaced with asterisks. Make a liar out of me. Oh, derp. SEP equals, quote, asterisk, end quote. I didn't actually make it a separator argument, right? I didn't give it a name. There we go, right? My name is Slim Shady. You can even use that to prevent it from printing spaces at all, right? If I copy and paste this line, put that there. This says, don't put any spaces between these arguments at all. There we go. My name is Slim Shady. No spaces. Now I'm going to copy these and paste them directly into the notes. That produces my name is Slim Shady. The next one produces my name is Slim Shady without spaces, but instead asterisks. And then this produces it all squished together, right? So what are we doing here? Demonstrate the SCP argument. It's okay to call it the parameter because it's defined differently in the function. Okay. And what do we do here? Demonstrate the end parameter, which controls whether the print function goes to the next line. It dictates what is to be printed after the data instead of a new line. You know what the new line is? It's the \n, right? If you want to print a whole bunch of blank lines, I'm going to delete this probably, right? So it's just going to print out hello with a whole bunch of lines before it and after it. So that's the new line, right? I'm using the word hello too many times. Why don't I put something else there? Wowzers. So /n means new line. And then replace the new line with this obnoxious string. Replace the new line with a space. An example is too long. It's not going to look good in the notes. Oh, well. Don't know what to do about that. Onward. So one built-in function is the round function. Now, if you use the int function, it rounds it down, right? So 2.99999 rounds down to 2. It'll round it up or down as it needs to. Whereas int always rounds down. So if you have a is equal to the round, well, here, let's set a equal to a value of 5.99, and then b is equal to the integer version of a is going to equal 5. If you set it equal to the round version, you know, anything above .5 rounds up, right? 5.5 would round up to 6. 5.99 rounds to 6.
But it won't round it unless you set it to round, right?
Correct. Right. Yeah. So that's why we have, oh, what do you, thank you for correcting me. Thank you for correct. Oh, come back. My mouse is acting crazy. Oh, it's never mind. That was annoying. I don't know what I did wrong there. All right. So you're correct. I needed to put the word round there. You can also dictate how many decimal places you want to round to, right? If I have the number A is equal to 3.14159 and I just want 2 digits, I can do B is equal to round A to 2 places. So you'll get 3.14. This is another example of an optional argument, right? This one only took one argument, but then we tacked on a second argument, which was a number of places. And when I want to round stuff, I don't know, like if I have dollars and cents, right? If I calculate the price, total is equal to, 37 dot, right? We might want to round it, right? Why don't I just use that shorter word? Price is equal to the round of the price. Is that how cash registers work, or do they always round down? I don't know. So anyways, and then if I printed it out, it would just be, wait, let's round it to 2 places so that we have dollars and cents, right? Print a $sign plus the string version of the price. I don't know if that's going to work. Let's just print out the price. All right, and we got 2 digits. The only problem with what I did there is that it's not going to be formatted correctly if it only has 1 digit to begin with, right? If I do that, I think it's just going to print out 37.6, even though I said to round it to 2 places. Now we can dictate when we print how many digits we want to display, but we will do that another day. So let's keep the example as it was because it's close. It's close to being correct. Oh, maybe I ought to show you the whole way of doing it.
That's all up to you.
So if we import the math function, we have the value pi. Let me make sure I'm doing this exactly right. So I'm going to test it in the shell first. Import math. And then print out math.pi. Yeah, okay. So if I want to print out pi to 3 decimal places, I would do it like this. And there's like multiple ways of doing this. And I'm going to hope that I get this syntax right and don't botch it. I'm going to print pi is about equal to math.pi. Now, if I do that, it's going to print out the whole value. Oh, what did I do wrong? I forgot to put the F there. Formatted print. Put an F before the string. Use placeholders inside these things to dictate what gets printed. And the data to be printed can be formatted by using codes inside the braces. So I'm going to say that I want this to be printed out to 2 decimal places. And it's a floating point number. I know this is looking complicated. I don't really expect us to remember it right now. I just want you to see it and then remember it the next time. Right? And so pi is equal to 3.14. Whereas if I'd left that out, it would have printed out the whole value. The dot 2f means display only 2 digits of the float after the decimal point. Now, normally when I use this placeholder syntax, I don't get so specific, right? I think I can even get away with losing the F there. That'd make the syntax a little bit clearer. Nope. Oh. For one thing, I forgot my closing brace. Yeah, it looks like we're going to use up all of our time on the chapter. Why did it only display 1 digit? I don't know. I'm going to put the F back because that did work. Okay. Like that. All right. Normally, I only use the placeholder for 2 reasons. One, if I'm going to print out multiple variables in the same sentence, in the same output, or 2, if I need specific control over it. So like if we have 3 variables, my name is Slim Shady. He's about 50 something. I don't know how old he is. Let's say that he's 54, 43, and he lives in Detroit. And we wanted to print all that information out on one line. Okay, so print, and it's a formatted print, so I'm going to put an F there, quote, placeholder, name lives in, placeholder, city, and is, placeholder, age, years old, end quote, in parentheses. So it's going to print Slim Shady lives in Detroit and is 43 years old. And again, this syntax is not shown in the book because it was invented after the book was invented. It was invented like for version 3.5, but it's so useful, I want you to see it. Right? And there we go. It filled in the placeholders. Slim Shady lives in Detroit and is 43 years old. Tell you what, I'm going to copy all 3 of these, paste them into the comments. So this one hooks up. I did a botched copy paste there. So that produces that. I'm adding some white space because I want to explain what this entire block of code does. Now we're going to print out the Slim Shady line. So that was Slim Shady is blah, 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 blah. And I accidentally cut this and put this at the end. Sorry about that. More copy paste. I wish I hadn't botched it. It's taking more time than it requires. And then we had this one. Okay. So a function is a chunk of code that can be called to perform a task. Functions often require arguments or parameters. Those are the things that are between the parentheses. When a function completes its task, it may return a value. And we're going to be talking a lot more about functions, so it's not like we have to nail it all today. but a function can return a value. Like if we want to convert Fahrenheit to Celsius, we could write a function, F2C, and it's going to take a number. It's going to take the temperature in F. And so to convert Fahrenheit to Celsius, we multiply it. So let's say that the temperature in C is equal to the temperature in F times 1.8, no, divided by 1.8, and we should have subtracted 32 from it first. So it's equal to the temperature of F minus 32, and then that has to be in the parentheses, and then we need to divide it by 1.8. And if you Google it up, then you'll see other formulas, but this one probably works too. We'll test it, right? We're going to say that A is equal to F2C of 212, which is boiling. So that should be 100 in C. And then B is equal to F2C of 0. No, 32. 32 is freezing point, which is 0 in Celsius. So let's print boiling is namespace A degrees C, end quote. And I've forgotten something. I forgot to put the F there because I'm using a placeholder, so I got to put the F there. And then print F quote freezing is placeholder B degrees C. And I just want to make sure it says 100 because that means that my function is correct. It's not correct. I'm going to run it and show you what happens when I botch it. Well, for one thing, I'm getting an error. Invalid syntax. Yeah, on what line? Why didn't you tell me what line? Oh. I meant for these to be comments, and since they're not comments, it's trying to interpret that. Now, it's funny that it accepted it all the way up to that point, because how is this good programming? How is that valid syntax? I don't know, but I'm going to comment it out. So it'll run. Now, I have a programming error that's not a syntax error, but it is a programming error. The programming error is that my function is not returning anything. So it's printing out none. Not what I want. I want it to actually print the number. So when that when this function is done calculating, it needs to return what it just calculated. So let's add a comment as to what we're showing here. Functions can return values. This function converts the temperature F parameter to a temperature in C, which is Fahrenheit to Celsius, and returns that result. If we were awesome, we would put a docstring here, convert Fahrenheit to Celsius. Is that absolutely necessary? No. Is it good programming? Yeah. All right, so now it should work, right? Because I have the return statement. So when this happens, F to C 212, the 212 gets copied in, fills that. So it calculates that temperature minus 32 divided by 1.8, and then it returns it. So that returns and gets stored into A. Same thing here, right? 32 goes in, calculation happens, return back out, stores in B, so that we can then print those values out. Now I have a really fast Mac, and it's annoying that Python prints so slowly to the screen. The graphics on this Mac aren't that bad. I don't know why it prints so slowly. It's Python's fault. Anyway, so boiling is 100 degrees C. Freezing is 0 degrees C. So those functions are working. Functions don't have to return values. in which case they just return none, right? If it doesn't, it actually returns none, which you could print out, but you're never going to really use it, right? So the math module. Math has got things like ABS and round and pi and square root. Stands for absolute value. Pi, round. Now I'm going to put parentheses after these to differentiate it from pi, because pi is not a function, right? It's just a number. And SQRT. There's two ways you can import things. You could do this, import math, and then print math.sqrt of 100, which is 10, right? And print math.abs of -4, which is just 4, right? Print math.pi. Print the round of math.pi. If you get annoyed at having to type math dot in front of everything, you can import them specifically with this syntax. From math, import sqrt, comma, abs, comma, pi, comma, round. And then when you print these things, you can leave off the math dot. It's just a matter of preference. It's kind of nice to have to put the math dot, because then you know where the function came from. On the other hand, oh, see, this wasn't going to work. I'd already included. It's lying. Round is part of the basic language. It's not part of the math library. So I'm going to take that out. That must have been added in Python 3 because we were using it earlier, right? So anyways, this should work just as well, and we're not having to type in so much. So two different syntaxes, and you'll see me switch between them, right? I did import turtle, but if the inside the random function, the only one I want is randint, I could do that, right? From random, import randint, which is a random number generator. And so a is equal to randint 1 to 10. Generate a random number between 1 and 10, inclusive, right? It can get a 1 and it can get a 10. Print random number was in quote comma a. La-di-da-di-da, math has no attribute ABS. Well, what do you know? Let's open up the shell and just ABS of 10. All right, that was moved into the base language as well. Delete that. Delete that. Get rid of that comment. And then I'm going to add a comment to the effect that round and ABS are now part of Python by default and not in the math library, like the book says. All right, hope that makes sense. Two different syntaxes. From, now you can even try this. From random import star. Hopefully that'll bring in everything from the library, but I've seen at least one example where it doesn't work and it says the function call is undefined. So why not use that all the time? I don't know. I like just seeing the word of the function that I'm going to be using. So when we import it, we don't need to put the round function. I should have known by the color. If the color is purple, then it means it's a default function. It's a built-in function that did not need to be imported. All right, we are about done with this chapter, although we will come back and I think I'm about ready to stop here. See, this would, okay, that's valid because pi and square root, or you can do from math import asterisk. Yeah, we're stopping here. We're stopping here. All right, so let me pause the recording while I go fetch the next homework assignment. So our homework, write a program that asks the user for the radius and the height of a cylinder. Have it calculate the volume and the surface area of the cylinder. Have it display the results. If you can, make the output look like this. What is the height of the cylinder? I'll fix it. Oh, come on. And they type in 10. What is the radius of the cylinder? 10. Let's go find out what it really is. So if we type in 10 and 10 here, it's about equal to 1256.64. And then the volume of the cylinder is about, because we're going to be using pi, which is an infinite number, the calculations will not be. A perfect round number, right? All righty. Use Google to find the formulas. You get stuck, text me. I'd like for you to use math.pi, right? Rather than 3.14159. All right, so that's the homework. It could probably be written shorter than it took me to write the assignment, but that's okay. If you want to use formatted output to force only 2 decimals, like I showed up here with that .2f, great, go for it. If you just want to use a regular print statement, that would work as well. It's going to print more digits. You could use the round function to force it to 2 digits, but I don't care if it's exactly 2 digits or not. Right. It's great if you do. If you get stuck trying to do that part as well, feel free to ask. All right, I hope that makes sense. What page did we get to on the PowerPoint? Let's take note of that. We got 238, so we got through 37. Make note of that. Alrighty. So this is just silly, right? But anyways. All right. I'm going to run it one more time, make sure there's no syntax errors I added, which is common when I add the homework assignment. Yeah, I forgot to close the, with triple quotes. Where is it all? Looks like I have some notes at the very bottom that I'm going to need to move up. Alrighty, gang. There's a Dropbox, so you can fill out a lecture review form and upload it. Let's make sure that the Dropbox is active. Take a peek. Week 2, no, it's not active. Is now. So go ahead and upload a review form and tackle the homework. And this will be due in a week, of course.
All right, sounds good.
All righty. So I'll see y'all on Wednesday.